Okay, so let's do some LeetCode daily. Next greater numerically balanced number. Okay, so an integer x is numerically balanced if for every digit d in number x, there are exactly the occurrence of that digit in x. Okay. Given an integer n, return the smallest numerically balanced number strictly greater than n. Okay. Okay. So my first idea about this question is that we can build a whole list for the every numerically balanced number and store them into a set or a list. I think maybe in a list, and this will be a sorted list. And no, in that case, we can just basically use the index and +1 to find the answer. But it's really hard to build a whole list for every numerically balanced numbers, right? Because the constraint n is really huge, so we cannot do that. But there is something that we can do is because we want to find the next greater numerical balanced number, and that is the smallest one. So we can apply the greedy strategy and to calculate how many length for the current number and how many number we need for the next value. So there's two cases. The first case is like for example one, we need actually it's balanced. So it's balanced or it's not balanced. Right. So if the current number is balanced, increase the length, or we can change the order. Right. Make it balanced. Find the minimal valid. Right. So you have to go like this. Right? Alright, so wow. Actually, I'm thinking about how many combinations that we can have. Because if that is one, then only one possible. And if it's two, we got two, right? We got only two. And if three, we actually got one, two, or three. Right? And if it's four, we got one, three, or four, 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 four. So, does that help us? Well, I don't think it's really do, so. Oh, so actually it's not really bad, right? So if the length is 5, what's the combination you have? Because the max value is 10 part of 6, so that would be 1, 2, 3, 4, 5, 6, right? So the maximum is 7 actually. So yeah, we already come up with almost every combination here. We got 6, we got 1 and 5. And 2 and 4 actually. 3 and 3 is not valid, and 4 and 2 is the same as 2 and 4. And for here we got 1 and 6. And 6 itself actually. 1 and 6, 2 and 5. 3 and 4, and all 7, right? So actually all the, oops. Well, all possibility for here, right? What the fuck is going on? Yeah, so basically, actually, we just have to generate the whole list for this one, and then use binary search to search the max value, which is strictly greater than n, right? All right. Yeah, I don't think that's too much. So basically 1, 2, 3, 4. I got 5 over here, 6 over here. All right, so length, lemma. You got this right. So for 5, we got 1, 4, 2, 3, single 5, 3, 6, we got 1 and 5, 2, 4, we got 6 itself, 1, 6, 2, 5, 3, 3, 4, 7. Perhaps I'm missing something. 2, yep, 4. Is that more? 1, 2, 2, 3. Over here, actually, it's 1, 2, 4. Okay. So this is the map, and we basically just do the backtracking. Find all com, find none, sure. Hold valid. And then you just sort hold valid. Binary search the leftmost larger than n, and that'll be it. So let me tidy it up a little bit here. So, well, let's do the backtracking, and we want to do for a key in lemap, for length in lemap, we want to do the backtrack. Okay, for well. And we also need a frequent map. list in. Li. Yeah. And for backtracking, combo here. If right. For I in combo. Okay. Let me just use bisect, okay? So yeah, let me just validate the solutions work, and then we can do the manual binary search over here, okay? Okay, if not freak. Oh, freak map. Freak map I, freak map I, freak map I. Oh, integer is not a variable. Oh, why? Oh, for li. Oh, it's over here. 7, right? Right. Oh, because bisect. Okay. Oops. Right. That would be correct, I think. Okay. All right. So yeah, if we are in the end interview and we cannot do the bisect, we can just implement a simple binary search to search the lower bound, right? So the target is actually n, right? So we can replace the bisect up here and then it's there. R equal to 0 is all valid. So check 1. Right. And y else more than equal to r and equal to dot plus r divided by 2, and if all valid bigger than or equal to all equal to n, all valid m bigger than n, we can update our right pointer to n plus 1, else we want to move the back pointer. And since we want to get the lower bound, and in the last not valid number, I mean for the last valid number, we will move our right pointer. So our right pointer will be n in a not valid position, and so we want to return L, that pointer, for our last for our lower bound index. And yeah, this would be the same. Okay. Okay. So yeah, that basically is today's daily, and I would say it probably looks so much combination over here, but it actually not. If you just try to break down how many combinations that have, it's not really much, right? And I would say to create this hash map is not really intuitive, but once you think about it, actually we can just create a whole list, right? And use the backtrack to generate all the permutation and do the binary search